Selamat datang to tuan-tuan dan puan-puan sekalian. Selamat pagi, selamat sejahtera, and a very good morning to all of you. Ladies and gentlemen, thank you for spending your precious time this morning to attend this remarkable and interesting webinar session titled Aircraft Maintenance Engineer as Effective Project Managers by T.S. Siva Pragathesewaran. Hopefully you are in the right webinar. I trust you are in the right webinar. But before we start, let me introduce myself. My name is Kean Shiung. I will be your moderator for this webinar. And I would like to disclose that this topic is very close to my heart. Why? Because I started my career as a trainee aircraft maintenance engineer and subsequently became a licensed aircraft maintenance engineer and quality assurance inspector. I have spent 30 years of my working career in aircraft maintenance, and it has been a very rewarding experience. So as you can see, it is very close to my heart, this topic. So before we proceed, first of all, I would like to welcome and thank the organizer of this event, Professor IRTS Dr. Abdul Rahim Abdul Talib, Professor of Aerospace Engineering Department at UPM. This event is also jointly organized by the Malaysian Society of Engineering and Technology, MySET, and University Putra Malaysia, UPM. A very big thank you to them. Okay, some house rules. Please mute all your microphones so that it will not create any unwanted acoustic feedback to the rest of us. If you have any questions, please write them down in the chat box. I will monitor it. I will post them to T.S. Siva at the end of his presentation. Okay, enough of me talking. I will let T.S. Siva introduce himself. And thank you and have an enjoyable webinar session. Okay, see you later. Over to you, T.S. Siva.
Thank you very much, T.S. Chin. Good morning to everyone. And thank you very much for joining the webinar. It's morning for everyone, and it's very, very early morning for me, actually. And thanks to MySET, Dr. Rahim, for your relentless effort, to make sure everything is successful, and T.S. Ricky. Okay, today's topic is going to be, it's called Aircraft Maintenance Engineers as Effective Project Managers. As T.S. Chin said, this topic is actually very close to my heart too. We are all aircraft maintenance engineers, and a lot of us are, and a lot of here the participants also basically are not. So that's one of the good reasons why we're going to introduce this topic, to show that why aircraft maintenance engineers can become effective project managers. Aircraft maintenance engineers, basically we call them AME. They are also known as licensed aircraft maintenance engineers, LAME, or simply LAE. That's the most popular terminology. We use it in Malaysia, LAE. Or even aircraft mechanics. Basically, in countries like in America, they call engineers as mechanics, or even ground engineer. So these are the many names. Like, as we know that many names of the same profession, as the saying goes, a rose known by any other name would smell as sweet. So whatever the name the LAEs are called, the professionalism remains the same. It's maintained at the highest level. This webinar is dedicated to all the LAEs. The presentation here depicts the day-to-day activity of an LAE. So let us begin. All right, in the introduction, we can see that there is a description about project management as stated by PMBOK. PMBOK basically is project management body of knowledge. It is controlled or under the guidelines of PMBOK guides and standards. The PMBOK by itself is quite very extensive. It sets the standards that the project managers must adhere to deliver a successful project, which involves leadership, team building, cost control, quality control, and monitoring, and so on. So the LAEs may not be a certified project manager through a formal process. However, the LAE goes through this process on the daily activity, which we will see after this. The structure falls in place automatically through the guidance from the peers and the rigorous practice. The focus here is basically on the project life cycle, which we shall see shortly. The Project Management Institute defines project management as a temporary endeavor undertaken to create a unique product, service, or result. So from these words that we can see the word temporary, endeavor. And the final product is going to be whether it's a product or it's a service or a result. In this aspect, what we can see is what we are going to see will be service, because we are going to be focusing primarily on a line maintenance task, which is going to be a service and perhaps result oriented as well. Looking at this definition, as you know, we can break it down already to small sections. It is evident that the specific task undertaken must have a time frame. So this is guided by the time, with a definitive result to qualify it as a project. To fulfill the criteria of Project Management Institute's definition, so we have these are the core elements that it fulfills into. We have a time frame, we have a specific task, and a definitive result. In this slide, basically, we can see this relationship between the process and the outcome. The outcome is the goal. In any project, the final destination is the end product, the goal, be it a product or a service or a result. The bridge that connects between the person who executes the project and the goal are the processes. The bridge that we see, the man is standing there with a bridge and he's got a missing piece. Yep. This basically the bridge constitute as the processes. The processes must be solid and all of them must fit into each other perfectly. There you go. You miss the point, you don't get to the goal. Failure on any of this section can truly hamper the attainment of the goal itself. That is why so much time is spent on working on the processes to ensure that they are robust. As we can see here, there are some examples of what we call about the process and the outcome. Eating healthy. What is going to be the outcome? Weight loss, more energy, etc. So there is a correct process for the correct thing. Studying hard gives us good grades. Weightlifting, build muscle mass. Okay, now, for the sake of argument, just to say that in the sense of process, let's say our goal is to lose weight and gain more energy. Can we do it by studying hard? Okay, you study very hard, you might lose weight, maybe. More energy, I think you'll get tired. Eating healthy. Well, it can build muscle mass, yes, but that's not the end goal. Weightlifting causes us to get good grades? Well, I don't think so. So every process has a definite outcome. The outcome is the goal and the process is the way that we achieve to the goal. So this is a core element of project management. As you can see in this picture here, this man stands, this little person actually standing here, and he's standing on a very small stand here. He's standing on the basically on the initiation. It's an idea, and the goal is much big. That's big. That's your end product. Okay. Now this is a completely very interesting slide that I'm going to share with you. Yes, this is Lockheed Martin. There is a reason why I'm sharing this slide. In this slide, we see an example from one of the best aviation industries on how they deliver projects. Most of their projects are challenging in all aspects, especially in cost and technology. If anyone is interested, you may read books about how Skunk works. They create specific projects, like we have the SR-71, one of the most famous ever flown. The Nighthawk, the F-22, Raptor. The Skunk Works is actually the backbone of Lockheed Martin. Who is basically Skunk Works, right? This was founded by Mr. Kelly Johnson in 1943. He was commissioned by the government to basically create planes during the time of the Cold War. And Kelly Johnson, basically, he created and empowered a team who could actually they were completely detached from the organizational bureaucracy. They are free to determine the needs of the project and demand what they needed. Skunk Works, which is actually a registered trademark, is still alive until now. The reason I'm telling this is they are actually one of the best ever in the industry. In aerospace industries, Skunk Works, they're amazing. So Skunk Works project team was able to deliver the projects on time and within budget by adhering to clear focus on their mission, by extensive upfront planning efforts, by critically analyzing customer needs, leveraging on the project overlaps, early supplier involvement, and team empowerment. Two frequently offered reasons for successful completion of so much work in record time. The two very important things here is the existence of a project manager. Must have. Without this project manager, it's impossible that Skunk Works would have gone to the extent that they are becoming so famous the way they are. And the ability of the teams to actually concentrate in their work, right? Is removing the bureaucracy, having a great project manager, having a focus, having a goal, a definitive idea with a goal is what creates the best. And of course, the advantage of Skunk Works is that they are literally free from the political control. They have a free hand to do what they could, whatever they want actually, to deliver the project. Okay, in this slide, we are going to see about what we call the life cycle of project management. It has what we call controls. From what we can see here, these are basically the words what we call controls. A definitive beginning with an ending. So it starts with initiating and ends with closing. So these are the controls that we're going to see how the LAE is going to implement on its day-to-day activity. So the phase structure, these are the phase structures, allows the project to be segmented into logical subsets for ease of management. So it's been broken down into pieces, right? So the number of phases, the need for phases, and the degree of control applied depend on the size, the complexity, potential impact to the project, regardless of the number of phases comprising the project. And all phases, they have similar characteristics: initiating, planning, executing, controlling and monitoring and controlling, and closing. The one element here which is a bit more interesting is monitoring and controlling. Monitoring and controlling actually is a closed loop between the planning processes and executing process. It just goes around and around. So it's not a control separately by itself, but it's a control and monitoring which controls the planning and the execution process, right? So here is where a lot of quality control comes into picture, right? So this forms the core. The PMI is the Project Management Institute. So Project Management Institute is at the heart. So the heart of the Project Management Institute are all these controls. Now the question is, while we may argue that some work performed by the LAEs may not fall into the criteria of what we term as a project, our aim here is to draw the parallels between a project and an operational work. So even though it's an operational work by definition, it could be a short term, may not sound like a big project, but there are parallels. There are very lot of similarities, the way they act, the way they are executed, the way they are planned. So this is what we are going to see here. Next, we all know this, right? So just to introduce the great Airbus 380, the queen of the sky, or was it the king of the sky? Most of the airlines have retired it now, including Etihad Airways. We have retired. Of course, not Emirates, but most of us have actually retired our 380s. So the controls that we spoke about earlier, these controls are very, very important in delivering a very big project, like in the making of the Super Jumbo Airbus 380. So without these controls, the task can result in a failure, wastage, or even a higher cost, right? So an example is the production delay of the Super Jumbo Airbus 380. the world's largest aircraft. The failure was caused by the wirings, which at the time of installation was found to be a few centimeters short. This may sound absurd to us, like how a few centimeters could cause massive problems. But anyway, in aviation industry, which is one of the most highly regulated industry, there is no way that we can simply tuck or join the wires as we so desire. In the 530 kilometers length of wirings running through the fuselage, this error actually brought the project to a stop. So the root cause of this failure was basically identified with the root cause analysis at the design or initiating and planning phase, the very beginning itself. The project was shared among several countries which were using very different versions of their design software. They were using CAD, which is computer-aided design, and also CATIA, computer-aided 3-dimensional interactive application. But even among the CATIA users, they were actually using several different versions, which caused a mismatch. And these mismatches could be just very few millimeters, which resulted in redesigning and reinstallation of the wires. So these variants were omitted, thus creating a perfect alignment of the Swiss cheese holes, which we will see later in the next slide. This is a term used in the study of human factors, implying the cause of errors. And for every error, there is a cost. At the end, the aircraft that was projected to enter service in 2005 was only managed to be delivered in 2007. There was a 2 years gap. And the total cost for the delay to Airbus industry was estimated as a staggering 18 billion euros, or that's approximately 86 billion Malaysian ringgit. Really, really big. Okay, we are going to have a look at a slide here. It's called the human factors, the dirty dozen. All LAEs know this. We have to go through the human factors course, training. And this is only a depiction of the failures that we have seen due to failure in the planning and initiating phase, or even in any phase of the project management, like what we described for the Airbus 380 just now. So all these holes aligned perfectly. So this is what we call the Swiss cheese model on the aviation human factor. So it's also probably used in many other different industries. Maybe they have a separate model. So this is called the Swiss cheese. Swiss cheese has these holes. When all these holes are perfectly aligned, the safety net is broken. There's nothing there to stop it, right? So we have layers and layers of safety that is built in aviation, in aircraft maintenance. But when the holes are aligned, it's disaster. So among these, there's 12. Lack of communication, distraction, lack of resources, stress, complacency, teamwork, lack of teamwork, pressure, lack of awareness, lack of knowledge, yes, fatigue, one of the big factors, lack of assertiveness, and norms. Actually, norms also plays a very big role in causing this alignment of the Swiss cheese holes norms. Because of our daily practice, we think that we know about it. So, we do not adhere to the plan. We do not adhere to our initiation, planning, controls. We lose quality control by the means of simply norms. And this affects everything else that we have been working on, actually. So on this slide, we're going to be seeing we are entering into the core of the subject, which is aircraft maintenance engineering and project management, right? So now the question comes again is an LAE, right? What an LAE carries out? Is it project or is it just operational work? So we can see some factors here. In the field of aircraft maintenance, the principles of project management are applied at each stage of a given task. How this varies with other fields is the matter of importance emphasized by the governing of the regulatory. In our aircraft maintenance, the governing bodies are CAM, Malaysia, could be EASA, European, or the FAA, or any other governing body of the particular country. So the task, basically by the definition of the PM, you must have a definitive goal, and it is time limited. So the task itself then is further constrained by the requirements to meet the highest standard that is mandated by the approved documentations. Could be maintenance manual, troubleshooting manual, what we call for the Airbus, we call it TSM, troubleshooting manual. Then we have FIMs, fault isolation manual, this is for Boeing, airworthiness directives, and etc. Completion of the task must then be certified in accordance with the aviation law stipulated by the concerned governing of the country. Each task then itself is categorized as a project, and each aircraft maintenance engineer, AME or LAE, is a project manager. The time frame of a project can range from a short term, it can be minutes, then hours, that's for line maintenance. We have medium term in terms of days, and we have longer terms even for months for base maintenance or any other project of a conversion, for example, passenger to freighter, PTF conversion. Those are longer term projects. So this is basically the criteria. What are we looking at here is we have a time frame which is short term, medium term, and long term. This is basically a very simple description of the different time frames that we're talking about. So from the perspective of line maintenance, we have transit check. The transit check itself can be from 25 minutes, depends on the low-cost carrier. I know some low-cost carriers have a turnaround time of 25 minutes, or it can be up to 1.5 hours of a transit check time for a regular airlines. Let's say, even for us in Etihad Airways, for our Boeing 777, the transit time can be about 1.5 hours. A check, which is bigger than the transit check, can be between 400 flight hours to 750 flight hours, depending again on the type of airlines or the type of aircraft that we're using. The check duration can go approximately up to about 8 hours. So the duration between the checks is 400 to 750 FH flight hours, but the duration itself to carry out the A check is 8 hours. C check, come to the next one, C check. C check is a bigger check, it's much longer term, right? So it is between airframe hours of 2,000 flight hours or between 20 to 24 months, whichever comes first. And the check duration can go approximately up to 72 hours. Right. The next we have is the biggest check. It is called the HMV, heavy maintenance check, D check. It is an accumulated 20,000 flight hours, or it's between 6 to 10 years. But the check duration can go up to about approximately 21 days. This is very generic. It depends on the different types of aircraft that we are using. So other than that, this is a very general statement of what it looks like on an overview. What do we mean by line and base maintenance? This is what we see. Some of us know, some of us may not know the exposure. This is what we call line maintenance. Line maintenance is what we see in the tarmac of the airport. When we go to the airport and we look out from the window, and this is what we see. It's a very interesting sight, and it's really amazing actually. You just see that how so many people and vehicles, look at here, is interacting with the plane. There's a refueler, there's a loader at the back, there's a loading guy here, there's a step connected to the back, there's a passenger step connected here. We see a tow bar that's connected to the aircraft, and of course one is already up, taking off. So this is line maintenance. Line maintenance is what we were talking about, the transit time just now. Transit check is all done in line maintenance. A check, some airlines, yes, they do it also in line maintenance, and some also do it in base. It depends on the airline's program or their plan about how they do it. Like I was with Singapore Airlines, and I was basically doing the Silk-Air and Tiger Airways. We used to do the A checks online. The A checks used to be segregated into check 1 and check 2 on 2 different days. So we used to do it just in the line maintenance itself. But in Etihad Airways, we do it in the base. Yeah, so only transit check sheet and the others is done on the line, everything else goes to the base. And this is on your right that you can see this is base maintenance. Base maintenance is basically for higher checks, like what we described. It could be an A check, it could be even engine change, it could be, it is C check, it is D checks, or it can be even for any other work that they need to do. They need to change a landing gear, where you need to jack the aircraft. Some airlines even put the aircraft into the hangar just to change the windows. So this is base maintenance. Each project falls under the category of what we call scheduled and unscheduled maintenance. So scheduled maintenance is mandated by a maintenance program of the aircraft. ICAO, the International Civil Aviation Organization, defines maintenance program as a document which describes the specific maintenance tasks and their frequency of completion, the necessary for the continued safe operation of those aircraft to which it applies. So these are periodic maintenance tasks that must be completed to ensure that the aircraft remains airworthy. So this is it is a scheduled task. It's scheduled, like it says, it's mandatory. You've got to do it. It has to be done according to a plan. Unscheduled maintenance, on the other hand, is a non-routine task. Okay, yes, such as damage experienced by an aircraft during flight, due to a bird strike, maybe a lightning strike, system failure, or even more recently when we park all the aircrafts in all over the worldwide. So each parked aircraft itself has a further time-related maintenance tasks which are stipulated in the maintenance manual. So what I'm trying to say here is we categorize the checks into two different types of maintenance. One is unscheduled, the other one is scheduled. Right, so two different categories that we have here. Okay, we're going to have a short look on a transit check, what it looks like. And the reason I'm focusing on transit check is basically I'm a very, all my time I've spent in line maintenance. Okay, let's play a small video here. We can see. Right. This is a simple transit check sheet, and as per the video, it lasted only for 36 seconds. But not in reality. This is a 737 NG, Jet Airways. The transit could have been 45 minutes. So in a transit check sheet, in a transit check, so these are the basic things, items that we see. Arrival items, we have exterior checks, we have flight compartments check, passenger cabin checks, waste and water servicing, refueling, final item, pre-departure checks. So this is very basic transit. These 8 items have been derived from a transit check sheet. Right. So what we saw here in 36 seconds is actually much longer, and the LAE has to do all this. He has to read through the arrival items. He has to do an exterior check. He has to do flight compartment checks. He has to do passenger cabin checks. They have to carry out water and waste servicing just to ensure that the water and waste servicing is properly carried out. He has to monitor the refueling. He has to do the final items. And then he has to also do a pre-departure check. And LAE has to do all this in the given span of time. Right? So this is a very short term. Transit check is very short term. It can last 45 minutes, 1.5 hours, depends on the type of the aircraft. All right, in the process, now we are getting into the core. We are reviewing the transit check sheet. Right, we are reviewing the transit check sheet. We are taking the transit check as a project that the aircraft maintenance engineer or the LAE basically looks at. So how does a transit check constitute to a project? If we break it down into smaller pieces, then we'll get the process itself. The first one is initiating. The AME reviews the transit check sheet. Every check that is performed by the LAE is as per the approved document. The LAE must go through the steps as stipulated in the check sheet. The certification that he does, or the LAE does, he or she carries out, is known as the CRS, the Certificate Release to Service. The notification is received through the ACAS, which is Aircraft Communicating Addressing and Reporting System, or it can be the Airplane Health Monitoring System, AHM, but we use for Boeing, or AME for Airbus. Other aircraft types will have their own system developed for the real-time monitoring. So before engineer goes to the aircraft, before even the aircraft arrives, the LAE has to prepare the transit check sheet. He will review the transit check sheet. The LAE also will get information from the MCC, Maintenance Control Center, who actually tells that there is an incoming fault or an incoming defect on the aircraft. MCC has access to real-time monitoring system, right? Because aircraft actually is feeding real-time data back to the ground, so we can actually see, and then we can plan accordingly, right? So the AME, then the LAE receives the notification of present faults reported by the aircraft or by the crew. The crew can even send a message. Some of these faults are just observed faults, which does not appear in our monitoring system. So in that case, the crew actually can send a short message, which we call the ACAS message, to the MCC, to the station. And MCC actually will then relate the message back to the AME, the LAE. So the LAE has to prepare this, right? So it's an initiating stage. So he prepares it. He's gathering all the information now. So the planning phase is more elaborate. In the planning phase, the LAE evaluates if the reported faults can be legally deferred as per the MEL, or minimum equipment list, what we call. This is a document that allows the aircraft to be dispatched. Right, with the minimum required item is a system redundancy, which can be dispatched without delaying the aircraft. The purpose of the MEL is to dispatch the aircraft so that we do not want to delay the aircraft. If the aircraft has a short ground time, yes, we can apply the MEL. If we do not have the required spares, then yes, we do apply the MEL to dispatch the aircraft. Right, and it must be rectified before next flight. Or it must be rectified before the next flight. Basically, the LAE evaluates the fault. And he determines, the LAE determines whether the MEL can be applied or the fault must be rectified. The MCC plays a very great role here, where they can check, they can inform the LAE, look, that you cannot, this is not an MEL item, so it must be rectified before the next flight. If not, the aircraft is an EOG, aircraft on ground. It is not fit for dispatch. The AME advises the supervisor on the nature of the defect, required manpower, and the spares. Works out the time frame. The LAE works out the time frame, how long it needs, by reviewing the maintenance manual, or the troubleshooting manual, or the film task, the fault isolation manual, prepares the tool, the spares, the materials as required. The AME debriefs the technician, the plan, and prepares for the execution for the next phase. If the time required to rectify the fault is more than the transit time, right? If the transit time is, assuming that the transit time is 45 minutes, and then the AME is aircraft maintenance engineer, or the LAE, then advises the supervisor, who in turn then will inform the relevant departments to make an aircraft swap, an aircraft change, or delay the flight. If so agreed, if you don't have an aircraft to change, you can delay the flight. This is communicated to the flight operations, network operations. They are informed and considering that the flight crew duty hours as well. So we do not basically get the crew to the aircraft and get them just to sit on the plane, because the crew duty hours may lapse, and that can even cause even bigger problems thereafter. So if the defect will be different in accordance with the MEL, then the operational penalties, like for example additional fuel, flight limitations that are stipulated, will be communicated to the network controls operation. So there are a lot of things that we got to see during the planning phase itself. This is actually one of the most critical part before the aircraft arrives, and doing a planning to really ensure that the transit or the dispatch is taken care of neatly and nicely. The next will come is the executing phase. In the executing phase, this is the real action, right? The AME and the technician, they are at the bay approximately maybe about 15 minutes prior to the estimated time of arrival. It can be 10 minutes, depends on what time. So we can take 15 minutes as an example. The LAE arrives to the bay. Just they have to go to the designated bay to do a scan, to ensure that the foreign is clear from the foreign object damage and the equipments are all ready as required. After the arrival of the aircraft, the AME and technician performs the transit check in the sequence as stipulated in the transit check sheet, like what we have seen earlier, right? We have the arrivals, we have the exterior checks. So there are sequences that actually LAE has to follow, assisted by the technician. The AME receives the debriefing from the crew on the technical status of the aircraft. A communication between the crew and LAE is very, very important, right? So when the LAE arrives and receives the aircraft, the crew will give a quick debrief about what the fault is. The LAE then will go up to the flight deck and review the defect and get a complete debrief from the crew on the technical status. If fault or faults are reported, the LAE performs system tests and evaluates the serviceability of the system. The defects reported in the cabin and in-flight entertainment system is also reviewed, right? It's not only the aircraft technical log, the LAE also has to review the cabin log and the IFE log. AME now coordinates with the technicians and divides the task to rectify the reported faults. The AME then starts the defect rectification process. The AME executes the task in the safest manner by coordinating with the ground staffs, for example, like cargo loading. If he needs to do an engine run, he will inform the cargo loading, stop the loading, catering, refueler, water servicing, tell them to clear from the aircraft, clear the aero bridge. So a lot of coordination goes into action at this time. Executing is actually really, really hectic. Like what we saw in the video earlier, like the 36 seconds, but that's a transit check sheet. There's so many people involved, so many vehicles are involved. And the AME has to be completely alert. And during this time of the process, during the executing part, it's a lot of work. Not only the LAE has to do his regular routine transit check, the LAE also has to fix the problem from the aircraft, the defect that has been reported. He has to fix the plane and at the same time monitor everything and going on, right? So this is the executing part. Then he also has to monitor and control. The LAE also works as a quality control to see the technician, to ensure that the technicians are actually doing a correct job in accordance with the manual, that the component is fitted correctly, that final testing has to be done. Make sure if it's a hydraulic component, make sure there's no leak. There's a lot of things that is involved, and executing part is one of the biggest stress factor that can cause. It can cause a stress factor at this particular point is executing. Monitoring and control. Work in progress. The AME now shifts to monitoring and controlling of the project. As I've described and we've seen earlier, the monitoring and controlling is not a single entity by itself. It's actually a loop between the planning and the execution. right? So there's a monitoring and control during the time of planning. There's a monitoring and control at the time of execution. So the LAE, or the AME, Aircraft Maintenance Engineer, acts as a project manager in a very short, for the given 45 minutes, short span of time, to do all this, juggle between from one state to another in a very, very short span of time. So in the monitoring and controlling, the work is already in progress. The AME now shifts to monitoring and controlling of the project. So throughout this process, the most important component is effective communication. It cannot go wrong. Like what we saw in the human factors dirty dozen. One of the things is lack is communication. The most important thing during this phase between the planning and execution is effective communication. Must communicate effectively. The AME monitors the job, checks and rechecks. Some of the tasks that carried out on the aircraft will demand what we call an independent inspection, as stipulated. Right? It's what we also call it duplicate inspection. In some airlines, we call it independent inspection. So some vital points, like for example, flight controls, engines, etc., of the aircraft will require independent inspection by a second AME to ensure that the disturbed component has been installed, adjusted, and is functional as required by the manual. The feedback is then provided to the supervisor, who in turn inform the flight and network operations of the technical status of the aircraft. Right? The AME has done the job. Right? So at the final, let's say for example, we'll take an example that a component is being replaced. A computer is being replaced, a flight controls computer. It has been replaced, it's been tested, an independent inspection by the second AME has been carried out. A test result is being produced. Let's say there is no further defect, there is no further test. The feedback is then sent to the supervisor, who tells the flight or network operations that the status of the aircraft is good to go. Or if the fault continues, right? So then again, the AME will inform his supervisor that the fault is now still present despite changing the component. So we need to troubleshoot further. Then that communication also again goes to flight or network operations and inform them on the technical status of the aircraft. So why this communication is so important is that the company can then decide whether they're going to ground the aircraft, whether it's going to be a flight cancellation, or whether it's going to swap the aircraft if there's another aircraft available, or just delay the flight. And there are a lot of things that go on here. We have experienced this. Even as passengers, we find that why is the aircraft being delayed? Right? So why is it being delayed? And then, we wait and wait and wait. And finally, sometimes we end up with say that the flight is cancelled for today. So there's a reason behind it. It's not that the airlines is doing it just for fun. It's a lot of cost is involved. But beyond the cost, the big play that we see at the background is this. The job that is done by the AMEs. The aircraft has to be safe. If the aircraft is not safe, we do not dispatch it under no cost, under no circumstances the aircraft is a go. We got to ground the aircraft. We have to ground the aircraft. That's why the communication is very, very important. AME takes up a very big chunk of role in determining the safety of the aircraft. It is them who decide. When the aircraft is on ground, the AME decides what the aircraft is like, whether it's a go, it's a no-go. We take the responsibility as AMEs. On the closing part, now that everything is done, okay, the component has been replaced, it has been tested, everything is fine, there is communication has been given, the aircraft is good to go, the task is now completed. This is the closing section of the task, of the transit check. We looked at the transit check. This is the closing part of the transit check, where in the project management, it comes as closing. So how does it translate to the AME, to the transit? The closing is that the task is completed. The AME and technicians technician, they review this, they review together, they review the system integrity and serviceability. Flight crew is advised on the status of the aircraft. The AME prepares flight for departure. At this phase, basically, the aircraft is declared as serviceable. We say aircraft is declared serviceable. So then the rest of remaining things continue. Whether we need the baggage loading continues, the refueling continues. Passengers are then will start boarding. So everything has been tested, everything is good to go. So this is the closing section of the transit check. What did we see so far from the beginning to the closing? We started with initiating, we went through planning, executing, monitoring and controlling, and finally closing. What we see here is on a transit check, a routine transit check that is done by an LAE. But even though it is a transit check, what we define as an operational work, but it consists of all the elements that is required by to qualify as a project, right? Classification of a project, that it must have a time frame, must have an end result, and it must be broken into pieces of these controls, what we call the initiation, planning, executing, monitoring and control, and closing. And we have seen this even in a simplest transit of an aircraft. So the AME goes through this on a day-to-day basis of his life. I'm talking about line maintenance AME. I mean, of course, base maintenance AME also have their own task, which constitutes as a project. But from the perspective of a line maintenance AME, even if that 45 minutes is so crucial, and the AME actually does this within that span of an hour, before the arrival of the aircraft to the closing of the aircraft, to the closing of the project. So this constitutes to the definition of a project. And why AMEs are very good at it? Because they have been trained over and over again from the beginning. So a lot of things comes through rote memorization, that's one thing, and the other thing is they have also been trained. It is nature and nurture. The AMEs have been nurtured to be excellent managers of their own, to work independently, to complete the task at a given specific time. In the airline industry, time is money. Yes, a delayed aircraft, an AOG aircraft costs money. Delayed aircraft, delayed slot, delayed connections. A lot of airlines basically work in a concept of what we call hub and spoke. So we have a hub and a moving spoke. Hub and spoke. Passengers come, they transit. The transiting passengers, they want to depart on time because they need to catch another flight from a destination which departs at a specific time. Sometimes the transit time for them at destination is just an hour, or maybe 1.5 hours, very, very short. So what happens if the aircraft is delayed here? If the aircraft is delayed at this destination, in the final destination, they will have to miss their flight, they have to take another flight, or they will have to stay overnight to take the next flight. So there's a lot of cost is involved in delaying an aircraft or an AOG of an aircraft. And European countries, actually, it's mandated that the airlines actually have to pay the passengers if the aircraft is delayed beyond a specific time. The passengers get compensated for it, and it's a cost for the airlines as well. Hotels, passengers' hotels, and so on, and arranging for the next flight, the crew flight hours, it's all being missed. So that's why it's so crucial, so important that the aircraft has to depart as much as possible. We get a good dispatch reliability, but at the same time to maintain the highest level of standards that we cannot miss. Right. We have seen so far the operation of what an LAE does on his transit check, right? On his regular transit check. How does this affect the decision making and the thought patterns of an AME? If we just look at the picture here, right, This is basically this is something that happens within us, but but we do not know, right? Some people, yes, do have a lot of interest in reading a lot about ourselves. Otherwise, generally, this is what happens. There is some thought patterns actually go through for decision making. It just doesn't happen by itself. A lot of practice is involved, And for LAE, this is from the perspective of an AME. So I use two terms, LAE and AME. Sorry, they mean the same, right? Licensed aircraft engineers, aircraft maintenance engineers, they mean the same. So let's review the thought pattern and decision making of an LAE in that transit check that we saw just now, in the transit check alone. So looking at the brain pattern here, right? So we have the left hemisphere and the right hemisphere. On the left, we have logical thinking, critical thinking, factual, technical, analytical, quantitative. And also, of course, we have conservative, structured, sequential, organized, detailed, planned. On the right-hand side, visual, holistic, intuitive, innovative, imaginative, conceptual, interpersonal, kinesthetic, emotional, a lot of other things, which is subjective. So we can divide it into left is objective and the right is subjective. So we can clearly see that basically the LAE at that particular moment, right, the LAE will be using a lot of the left side of the brain. Logical, critical, factual, technical, analytical, quantitative. Well, of course, if he's feeling very emotional, then it's a very different story. It will be unusual. Then the thought patterns are flipping to the right to be emotional during the time when he has to be logical, and to have a very high level of concentration because of the detail and planning. The LAEs are trained in this way, day in and day out, right? But that doesn't mean they are not emotional people. It's just that they know how to switch very quickly into very quickly they can switch into logical thinking. So thinking, technical thinking, is defined as an aptitude, ingenuity, and affliction for solving practical problems through experience. Right? This is Mr. Hansen. Hansen has said this, that the interesting part here is says solving practical problems through experience. But experience does not belong to the left hemisphere. Experience comes from the right hemisphere. This is from the long-term memory. This is through the practice, this experience. The LAE actually uses a lot of his experience during the time, especially during troubleshooting. Some of the troubleshootings, some of the defects that we see on the aircraft is completely new that we might not have seen it before. And some of the defects that are not even defined in the manual, we can't find it. It's not there, it doesn't exist. So the LAE, basically what they do is they use their experience. If they've had a previous experience with this defect, they know what to do, right? They use their previous experience, or they can even ask their peers, so their colleagues who had this previous experience of this very unusual kind of defect. This is the beauty part of working on aircrafts. And every day, sometimes it's a new challenge. We've seen new defects we have never seen before. It's very unusual. It's exciting and very challenging. It really make us to use a lot of left part of our brain, but at the same time, the right is also tapped in, right? Because the right constitutes to the intuitive, innovative, imaginative. So this is where the experience comes in. Or we find a problem in installing a defect, installing a component, right? So at that particular time, the LAE uses his right side of the brain. Very quickly it flips, right? It's got a very strong connection between the left and between the right. So it uses imaginative, innovative, how to get things done, right? Yet we have to execute everything in the given space, in the given time, and in the safest manner. It's most important. Okay, going a little bit deeper on this section. I do have a little bit of problem with my slide here. Something happened. Just excuse me for a while. As I described earlier, the critical and logical thinking process belong to the left hemisphere of the brain. The AME, throughout the life cycle of the project management described above, is primarily focused on this faculty part of the brain. The experience that the AME has previously encountered, which is stored in the long-term memory, is accessed through the right hemisphere. So what do we see here basically? An LAE or AME is able to use both sides of brains very, very effectively, left and right, very quickly, very swift. Okay, this goes a little bit deeper, but this is actually happening at the background, right? So this is some might call it a pseudoscience, but it is not. It's measurable. This is a data that can be extracted. I'm not sure if anybody has done any studies using EEG to find out what is the brain pattern of an LAE that looks like when the AME is, during his operations. But they've done a lot for the pilots actually. The pilots and the, for them, pilots have been studied a lot with the neurofeedback. These are the patterns that is derived from the neurofeedback, biofeedback sensors. In Australia, Qantas actually experimented with a lot of their pilots now during the COVID-19 to see what happens. So they put EEG machines and then they find out how the pilot actually, the alertness of the pilot during takeoff, landing, and critical phases of the flight, right? So for an LAE or an EME, this is the same. Because this pattern exists for everyone. We spoke about the brain. The brain has two hemispheres, left and the right. Yes, the brain, that is the brain, right? But that's behind it, behind the brain, or behind the whole functionality of us as humans. We have these patterns that controls us. For the alertness, for example, we have beta waves, which is between 16 to 30 hertz, which actually contributes to the alertness, concentration, and cognition. The AME, during his time, during the time where he's from the planning up to closing, he uses a lot of beta. It requires a lot of alertness, concentration, and cognition. As you can see, alpha, it is a more relaxing state. That's for a different type of studies. And you can see as it goes deeper, the level of waves becomes lower and lower frequency. Delta is the state of sleep, and delta is where our experiences are stored. When we spoke just now that the right hemisphere is from where we get the LAE takes this experience from these intuitions and so on. That experience or the memory of that experience is stored in the deep layers of the subconscious or the unconscious actually. This is where what we call the womb memory. It is stored at the level of delta, right? However, the most time the LAE uses beta. Beta is being produced by the neurons firing to the brain, using in the left hemisphere, a lot of thinking, a lot of concentration. It happens in beta. And for the innovative to tap his experience, he has to tap it from the delta. So there is an alpha state that is present as a bridge to bridge between the beta and the delta state. This, as I said, that this has not been tested on the engineers, not to the knowledge that I know, but they have tested this with the pilots and they find that its patterns are really amazing during the highest concentration level. The beta is not a flat beta, like what we say. The beta is a very smooth beta. It's a very high level of concentration and alertness. So why am I sharing this here? This is, I mean, of course, everybody has beta on a daily basis, right? But what I'm sharing is, it comes so naturally to the LAEs that they have a very good pattern of beta is because of the nature of their job. LAEs given a task and they have to manage an aircraft. It's a big machine. Safety is at the biggest point here. Really, really important. No slacks allowed. You cannot slack. So that's the reason why the alertness level goes really up. Really up. Very, very, very interestingly in a very beautiful pattern, actually. And it's very interesting. Let me just share something that I read before. It is said that Einstein, when he was writing his formula on the whiteboard, right, on the blackboard actually, not whiteboard, blackboard, they measured his brain waves and they found that Einstein actually exhibited extreme alpha when he was writing on the board. I mean, it shows his power of visualization and creativity, as you can see that, right? But this happens also to us at a different state when we are listening to a music, soft tunes, dim lights, close our eyes, we get these alpha forms. The alpha is so important that it is the bridge between the conscious and to the sub and the unconscious. Without the alpha, it is the experience and the memories are actually broken. Okay, on the next part of this section, know that I've been exploring a lot about the mind itself because it plays a very, very interesting role in what we discussed and why LAEs are very good at this. And you'll find a lot of LAEs are actually, they like to explore into the thinking is without them realizing it is because of their nature of their job. Edward de Bono has written a book, it's called The 6 Thinking Hats. Very interesting. Like we have 6 different colors here, as you can see. We have a white hat, which is all about facts, right? A yellow hat, positivity, optimistic, pro, the value, benefits, delightful maybe. The black hat, oh, really, taking back, judgmental. Red hat, okay, hunches, intuition, feelings, emotions. Green hat, expressing new concepts, perceptions. Blue hat, analysis. Why did Edward de Bono introduce this? He says we can actually visualize that we are wearing different color of hats. Like for example, if we are going to a meeting and we have to present, we have to come up with a decision, we have to give data, we have to present it to the management of certain facts that we have been doing. I don't think so we can be wearing a black hat. What is required is flip the hat, change a different color, a white hat, right? A white hat, that will be more suitable here. So just wear the white hat and go in. So facts, it's all about facts. Right? So me, now, doing this webinar for the first time in my life, I have really no idea which hat I have to wear. I think I chose my yellow hat. Being positivity, being optimistic, right? So that I can actually give a good one. But then every now and then, flipping my hat to the white hat, I changed my white hat. I don't think I want to wear my red hat at the moment. It's too much of emotions over there, it's involved, right? So it's just something very interesting. It's very good for everyone to explore into different ways of mechanisms of thinking, because a lot of this thinking can actually be nurtured, right? Some are, yes, of course, truly, they are born with a gift of this thing, but many other things can be trained. We can tame it. We can tame the mind. We can tame the way we think. And it is actually from the scientific point of view as well. And why am I showing this? Why is this so important? From the perspective of an AME. The AME optimizes this faculty by moving from one hat to another. Right? He flips his hat. Remember that from the initiation stage, he has to wear a different hat. He has to be very judgmental about the aircraft, incoming defects, problems. And then he goes into a planning phase, right? Then he flips his hat again. Okay, right? Data, information, white hat, right? So the hat keeps changing, but when he's executing, he's actually on the white. But to tap the experience, he might move to a different color, right? A different type of hat color. So this changes very rapidly, very quickly. Creative reasoning kicks in when a problem is encountered during the process, which may disrupt the flow of the work. So he changes his hat again, right? The brain is trained to jumpstart the various different types of hats, different faculty, rather quickly, given that the nature of the AME's profession. That is his job. That's his AME's job, he or her job, right? That is our job. We've been trained in such a way. Through years of training, this becomes emboldened and really, really pronounced. We don't realize it. LAEs actually don't realize it, but they have been really trained into flipping their thinking in a very clear way and a quick way. Okay, so this comes to the conclusion of my talk, or my webinar, my presentation. An AME goes through rigorous technical training, both theory and practical, and is subjected to assessments by the authority and the organization. The work itself requires in-depth application of aircraft engineering and system knowledge, professional skills, continuous learning attributes. Thus, the need to understand the technical language itself, logical thinking, and other factors as described in this article, basically in this webinar, makes an AME the fittest project manager available. It's true. The well-trained AME not only can execute aircraft maintenance projects, but also may well adapt into other projects. While the knowledge in the field counts, the experience and training and the making of an AME is the key to success as an effective project manager. And I here do conclude my talk here. This is the last slide I have.
Okay, thank you. Wow. TS Siva, I didn't know that as an LE I can right back to left and right for technical thinking, and this is new to me. Anyway, thank you, TS Siva, for the interesting insight of this topic. Very in-depth, very informative slides, and very enlightening on the subject.
But I must, one thing, TS Chin, one thing. I think I started the webinar without even introducing myself, right?
Okay, well,
yeah, I didn't flip my head. I didn't flip my head correctly, right? My brain jump started straight to the left. Anyway, everyone, I'm doing the introduction at the end of the webinar. Just make it a bit fun. I didn't want it to be too serious. My name is Siva. I've been 23 years in the industry as an aircraft maintenance engineer. I started with SME Aviation, then with Transmile Air, and then with KLM, Royal Dutch, based in Kuala Lumpur. I was 3 years in Singapore Airlines. And in 2009, I joined Etihad Airways, and Abu Dhabi is home at the moment. At the moment. Right? The heart is in Malaysia, but the home is here. Right? So this is me. Thank you. And yes, TS Chin, sorry for the interruption. We can go for the questions. I will try to answer to the best of ability. Okay. If I can't, then I will ask some of the experts in here, including TS Chin and Ricky. You know? Yes, please.
Okay, question time. Are you ready?
Yes, sir.
Okay. Before I open the question to the floor, I will start the ball rolling by asking my own question first. Question to you, TS Siva.
Yeah.
What challenges do you see for LAEs in relation to the subject of project management? What are the challenges you think they will face in aircraft checks?
The challenges can be many. Yeah? It's as I said, if you look at the controls, basically the problem with what happens is LAEs, they are natural project managers. It's just that we don't realize it. If LAEs understand the controls from initiating until closing, then it actually makes them simpler for them to break down the process and work more effectively. So what happens is that we are not exposed to it. Nobody taught us this, right? So we are just taught, okay, you got to do this, you got to do this, you got to do this, but nobody knows that each and every step is actually by a process itself. So what LAEs can do to overcome the challenge is to take up a project management course. If you want to be even a certified PMP, yes, please go ahead. I did project management as my master's subject. Right? I'm not a certified PMP, but it actually opened up a lot of things to me as an engineer that I like it's like an eye opener. I realized like, wow, we can actually do things this way, right? So did it contribute to myself? Oh, yes, it did. It changed the way I work. It changed the way I communicate. So the challenges is because the LAEs do not know the project management itself, the core requirements of the project management. It doesn't have to go into so detail, but the basic idea, it's very interesting. So you can, the LAEs can also visit Project Management Institute website. There are a lot of interesting information, like how to go about each and every step is also described in a very, very interesting way. So yes, there are challenges, and the challenges can be overcome by understanding the controls.
Okay. Thanks. I would interesting discussion. I would like to actually. I've gone through the chat box. There is a question by Prof. Abdul Rahim. He asked, how do you see the role of LAAs in the future with new emerging technologies, i.e. drones for inspection, artificial intelligence, etc.?
Yes, LAEs.
Over to you.
Yes, they're very good. We have drones, we have artificial intelligence, but it still requires an LAE's eye to look at it. The drones are very good. They can do very interesting crown inspections right on top, but somebody still has to view it. Right? The viewing eyes is still the LAEs. We are watching it. We have not come to the point yet where the AI can make decision. Yes, they can give us the data. Yes, they can give us the data, but then we, at the moment, will still have to do the final analysis and the repairs. Yes, of course, the AI might take over eventually, but even in terms of analyzing and doing a self repair, but that's not going to be in the near future. The drones are very, very helpful. We even boroscopes, we have very high advanced technologies that we do, that we use it, but we use it to make our job easier. At the moment, the LAE has to climb up to the crown to do a crown inspection, like especially lightning strike crown inspection. That is the worst thing to do. But we can do it with a drone now, which makes our job easy. But the final analysis is actually still done by the LAE.
Yep. Yeah, I agree with you. There's only so much artificial intelligence can do. Okay, let me open the floor to questions to all the participants in this webinar. You may ask your question. So please unmute your mic, ask your question, and we will try to get an answer from even from the participants. Please go ahead.
T.S. Siva, I have one question here.
Yes, Ricky.
How do you find the, let's say now during the COVID-19, LEs, many of the LEs are jobless now, and for them to actually transit into the non-aviation project management, non-aviation project management, how difficult do you think it will be for the aircraft engineers to adapt into the which whatever they have learned and do project management in non-aviation companies? What do you think about that?
Yeah, thank you, T.S. Ricky. Yes, I have thought about this before also. What happens even if I lose my job, what's going to happen? The thing is, project management, yes, but it is restricted. LAEs are project managers, but again, they are restricted to which different field. If it's very difficult to get an LAE as a project manager to the construction field, right? It's completely a different arena or area altogether with its level of expertise. But there are other faculties where the LAEs can actually go, power, production, right? Or even a management or even other engineering faculties, which is not too specialized into constructions or whatever. But the easiest transition that I've seen a lot of LAEs go into is either most of them, they go into power generation. And they do adapt very easily. It's very quickly. There is no problem in it. They have the skill, they have the gift to learn. And most of their skills are actually already there. It is only to enhance. So as long as the new job does not require them to learn the field all over again, like we have to go through 5 years of studies or experience, it is quite quick that they can adapt. They can do even their own business, become their own project managers into many other things, which is not too specialized. Yeah, I've seen a lot of people switch jobs, and a lot of them actually end up in power productions.
Okay, noted. What about the oil and gas industry? Will there be a very huge barrier for them to adapt in the oil and gas industry?
It's also possible. Yes, oil and gas industry is also possible. It is quite specialized, but oil and gas industry also have very, very limited, or what we say, there are a lot of scopes in between, because there is also a part of oil and gas industry where they use the ROVs, right? Remote operating vehicles. So yes, LAEs can do that. It's not difficult, right? Because LAEs work on the engines. Right, so it is similar, like how we operate machineries, how to read it, how like doing a boroscope. It's a remote viewing. Yes, it is. It can be done. It's not difficult. And also, oil and gas industry also takes LAE. They can take LAE in because there are only two basic industries, I will say that, which actually look into so much into safety, oil and gas and aviation. That's why aviation LAEs and pilots, they are normally very, very well noted because of their highest level of safety requirements. And to answer your question, yes, LAEs can go to oil and gas. They might just need to take a short course, but they can go. They can be very effective in it.
Okay. All right. Thank you. Thank you so much.
Yeah. Thank you. Okay. Is there anything else? I can see some on the chat box from Silver Money, Srinivasan. Major disruptors of the project plan will be the in-flight defects. Yes. Unlike the past, the LA is not burdened by discoveries in the tech log after the aircraft is parked. Software, for example, AME provides the data before the aircraft lands. It's very true. Airlines like Etihad will have invested in these technologies. I believe MCC will then be a key player in coordinating the tasks during the transit. It will be valuable to see how the focus on LAE has shifted to MCC with these technologies. It's very, very true. Like for me, I'm an MCC engineer. It's true. We inform the line maintenance or the other stations what is actually happening to the aircraft before the aircraft arrive. We prepare the spares. We communicate to them. But it could be also a shift. There will be a lot of shift into part 145, which they can play a role as well. The engineers can also get MN access. They can also get AHM access. AHM, the Boeing AHM is also viewable through the mobile phone, right? It's also there. If you have the access, you can even look at the real-time defects from the mobile phone itself. So there's nothing stopping the LAEs from getting the access. If the company is going to provide you the access, you can very well take it, view it, so that you can plan it yourself, that you know that, okay, I'm going to do this aircraft registration today. It's been given to me. So you go to the MN, you find what's the fault. Okay, all right, and then you can plan the things yourself. The thing is, you can coordinate with your supervisor or MCC saying that, hey, I noticed this fault, and this is what it is. This is what the MEL is going to say, and let's work together. Right. So that's a very good one, Mr. Silver Money. And from TS, Dr. Ravi, I'm embarking on this research for mental health research, EEG and other instruments with University Petronas next year, collaboration, Amity University, India. Yes. Very nice. Yes, correct. The EEG pattern that you showed, that we saw just now, that's very true. It's very interesting, Dr. Ravi. We can talk about it separately as well. I do have a biofeedback device myself. That's the reason why I can actually talk about it, like measuring the brain waves. You know, it's called the mind mirror. We'll talk about it separately. Okay, from Dr. Rahim, I already answered that question. And okay, and T.S. Chin, back to you, sir.
T.S. Siva, there is a question from Devon. He says, in your opinion, what would be the recommended skill an AME would need during this pandemic and also after this pandemic?
Okay, during this pandemic, I will really recommend all LAEs to take up technical writing skills. Technical writing skill is like, you know, there is a specific skill by itself. If you go to Coursera has a course on technical writing. LAEs are basically technical manual readers, right? We read AMM, we read the TSM, we read the FIMS. We are very technical minded. What I can suggest to you is for the pandemic and for post-pandemic, technical writing is a great skill. You know, there is a lot of requirements for technical writers. If you post it on LinkedIn as a technical writer, there will be companies which actually approach you, right? They will be asking for your services. So this is a freelance an LAE can do because it already is so natural for the LAE about the manual. I do highly recommend it. I took up a course in Coursera, technical writing, and I found that it enhanced my own skills in about how I can read, interpret, and write the manuals myself, right? So that is one of the best courses I can recommend for you at the moment is technical writing. And also do look into project management in the PMI website, right? If you want to become project management certified, by all means, yes, please.
Okay, thank you for the response. Another question here. One of the participants would like to ask, due to this COVID-19 outbreak, do students that are currently studying in aircraft maintenance field, what are the opportunities they have in the future?
Yeah, these have to be, as you know, the cost because of the pandemic, they will have to wait, or they will have to look for different type of area at the moment for a while. I mean, that's all I can say. I mean, every single company or every single airline is basically downsizing. Lufthansa, Qantas, Etihad Airways, even Emirates. So in the very near future, we may not see much. The students can actually adapt to a different faculty altogether. Any other aspects of mechanical engineering, which will be good for the AME. You know, but or if the AME is interested in training, the AME can also become a trainer. A lot of AMEs become trainers, right? You can teach, because the student as an AME has got a very strong basic foundation of the basic engineering of the aircraft maintenance. So you can even become a teacher, become a trainer. So there are other faculties that you can actually look into until you find an opening back in the aviation. We don't know when it's going to be, right? It could be 2021, maybe the mid of 2021, maybe 2022, but that's not going to be a showstopper. COVID-19 is not going to be a showstopper. We have the resources available that we can use it. A lot of courses are also now conducted online. So I think as a student, it is great to become a trainer.
Okay, thank you. Is there any other questions? Please unmute your mic and ask your question.
Okay, so I have one question here. This is Azim.
Azim?
I'm from Malaysia. I'm in Malaysia at this moment.
Okay.
Okay. When I joined this industry, okay, our LAE career in 1996, it is a very promising area, I can say. Everybody talking about aviation, especially in Malaysia. That time we have our biggest MRO in Rubang, and then we expand into few others airline, low cost carriers come up. So Malaysia aviation industry is going up. And then at this moment, then slowly, even before the pandemic, the aviation industry in Malaysia is like slowly going down and almost collapse. Do we have any project teams amongst the engineer to develop back the aviation industry in Malaysia?
Azim, thank you for the question. Yeah, it is very true, Azim. In 1996, because I also started somewhere around there, 96, right? We are at the same time actually. I joined SME at that time. You know, at that time it was like the peak. There was Transmile, Aero was big, MAS was very big. Yes, it is very true that we see that the growth was very, very high. Aerospace industry, aviation and aerospace industry in Malaysia was actually booming towards the boom. It was easy to find jobs at that time. There was no problem. And as you said, that the decline that you see. So if you want to know if there's any projects related stuff for the LAEs that we can do to revive the industry, I will recommend you to contact Mr. T.S. Ricky Liu. T.S. Ricky Liu is a very involved person. So we have LAE MySET as a group. We also have TAM, Technology Association Malaysia, LAE as a group as well. So you're most welcome to join us, right? So we can then discuss the many other things that we are planning to do, or what is the future is going to look like, right? So that will be the best area to look into. Yeah.
Okay, thank you.
Yeah, if you join the group, that will be very good, and bring your friends along. That's the best platform we have. We need LAEs to join us in that group, so we can develop the better future for ourselves together.
Yep. Thank you for the question, and thank you for the response. Is there any other questions? Please unmute your mic and speak. Ask your question. Okay. If there's nothing further, dear Siva, should we close the session, or do you have anything else to conclude?
I think I have spoken so much already, so much so I'm so hungry already.
Okay. And yeah. Very informative session.
Thank you.
Okay.
I would like to thank you, everyone. Yeah, thank you, everyone. Thank you, T.S. Chin. Thank you, Dr. Rahim. Thank you, Ricky Liu. Thank you to all the participants who joined this morning, asking wonderful questions, and hope to see you all again sometime very soon.
Okay.
Back to you, T.S. Chin.
Okay. Professor Dr. Abdul Rahim, before we close, do you have any final comments?
First of all, thank you very much, T.S. Siva, for the excellent presentation. I believe it would benefit a lot of people, especially those who are in the industry and the students. And of course, T.S. Chin for moderating the session. I believe now the industry people are taking over the webinar. So this webinar is actually the series of aerospace webinar. This is the 7th series of aerospace webinar organized by MySET, National Society for Engineering Technology, and of course jointly with UPM. And I believe many of you, maybe this is the first time you heard about MySET, and as said by T.S. Siva just now, MySET has just recently approved the working group on or interest group on LAE. So all are welcome, and whether you are a student, whether you are industry players or you are academics, you are more than welcome to join the LAE interest group. You may contact T.S. Siva or you may contact me, or I just already paste the website of MySET in the chat box, and feel free to visit the website, and I wish you the very best and stay safe. Thank you.
Okay, thank you, Prof.
Thank you,
Rahim.
everyone.
All right, we have come to the close of this session. From my last review, we had close to almost 30 participants. I think some of them are coming even from the Middle East, and I think there's one participant from Mauritius, other than Malaysia, of course. Okay, finally, I would like to thank T.S. Siva, Prof. IRTS, Dr. Abdul Rahim Abdul Talib, MySET, and of course UPM for this webinar session. Thank you. We've come to the close. Have a great weekend. See you soon. Stay safe, and bye-bye.
Thank you, everyone. Bye-bye.
Thank you. Bye-bye. Thank you. Thank you, T.S. Chin.